In the last video, we worked on insertion into a doubly linked list. Next, we'll look at deletion. We'll check for the same cases, deleting from the beginning, the middle, the end, an invalid index, and an empty list. In the singly linked list case, we needed a pointer to the node before the node being deleted, because we needed to be able to change that node's next pointer. But in a doubly linked list, we don't need to stop early, because the node being deleted has links to the node before and the node after. So let's start by writing the traversal that gets us to the node that we need to delete. At the same time, we'll handle the error cases. Here's the basic traversal that walks over the entire list. We want it to stop when we're at the correct index, so let's add an index counter and stop it at the right place. How do we know when we stopped in the right place? Well, if our current index is not in the right location, then the index was invalid. But what if the list is empty? If there's nothing to remove, then we can't even set the toRemoved node pointer to a legal node. Let's try it. So, if we get past that guard, then we have a node to delete. Deleting from the middle is the normal case, so let's handle that first. Order is important. We need to update the nodes preceding and succeeding the node being deleted first. Take a look at these pointers and read them left to right. If you're not sure what pointer is being referenced, pause the video and refer to a diagram. We could just return a removed node now. The list doesn't know it exists anymore. However, it's not good style to leak information about your data structure. So just to be careful, let's make sure the node we're returning doesn't know anything about our list. Great, so removal from the middle works, but that leaves 4 cases, removing from the head and tail, and then some mixed commands that probably require these cases. As you might expect, both of these cases require that we guard some dereferences. Let's start by considering the case of removal from the front of the list. In this case, we need to update the list itself, star list, and we need to make sure that we don't dereference toRemove previous. And in the case of removal from the end, we need to make sure we don't dereference toRemove next. What should our condition be? We can't rely on index to tell us we're at the end of the list. And that completes all of our cases, and our code passes all of our tests.